Alright, let's quote it down. Okay, so we finished chapter 1, but I would like to do a chapter 1 test, not today. I'm going to give you today to revise for tomorrow. So tomorrow's session we'll be doing a chapter 1 test. Okay, we're moving on to, and I'm only doing it Wednesday just because every other class is now allowed on Wednesday. Otherwise I would have done it today because we have a double session. But instead I'm going to use this double session to move forward. We're going to do chapter 9 now, differentiation. These are the answers to your exam question sheet that you received in the first lesson for 1H. So if you just flick through them. Oh, actually that's the problem I mentioned about, remember similar triangles? And I said the only one time they used it was 2010. That's a 2010 paper with the cylinder, the cone, and that's a similar triangles problem. So just to remind you, you can see that's your triangle. You are given the height, entire height is 10, and what you could do is model it. You can have R and you can remodel this height. And you know that's 2, you can remodel the height and you just rewrite the equations using similar triangles. Okay. Yeah. Anyways, once you can model it, the problem is really straightforward. Once you know your calculus, volume, sub your values in, and find H and whatnot, maximum, minimum, using calculus. But the hardest one for that year was modeling, because if you couldn't do the first part, you can do the rest. It just wouldn't work. That's why. Okay. Anyways, for today's session, first principles was more of a year 11 concept that you were required to know how to do, but I'm going to use the first principles to describe what the derivative is or what it means when you differentiate. Okay? But what you really need for year 12, first part, derivatives of x to the power of n. So that really just falls into power rule. So it could be x to the power of half, could be x to the power of negative 3/4, and you should be able to find the derivatives of that. And obviously we're going to learn log, sine, cosine, and tan. Those are your basic ones, but they all fall under this dot point 3 of calculus area study 3. Area study 1 was functions and graphs. That's what you did in chapter 1. This is now under calculus. Okay, there's 4 area studies. And then your key skills, dot point 11, which again, derivatives of polynomial functions. Just that. Okay? And obviously you have to be able to find the derivative of sine, cosine, secular functions as well. Alright? So 9A and B sounds really simple, but there's a lot of questions to do. And some of which I don't know your level yet, so I don't know what really ticks you off as in what makes it hard and what makes it easy. The concept is easy. I can teach you the concept within, 15 minutes. And you should know how to do 9A and B, but I find that every year there's some sort of questions that in calculus it seems to get students. For example, if I added an angle in, if I somehow mentioned that a tangent crosses, 0, 1, passes through 0, 1, and it makes an angle of, let's say 45 degrees with the x-axis, and the curve is an x cubed minus 2x squared, and I ask you, find the equation of a tangent line. For some reason, that's much harder than me just saying, find the derivative of x squared, x cubed minus x squared. You'd have no troubles doing that, but you'd have troubles interpreting or visualizing what you're meant to do if I add in an angle, if I add in the word parallel lines, if I add in the word perpendicular line. For some reason, that becomes harder. And the whole chapter 9 leads into that idea and gets you to chapter 10. So what I want to do is give you the overall background of what derivative is really doing, and hopefully that helps you to answer any question in 9B that you might find difficult. Okay? Or even 9A. 9A is just scary with the notation, but if you understand what it means, it's really not that hard. It's literally going back to year 9 mathematics on gradients. Okay? So copy these notes here. The first 2 slides is really where all the theory is at, and then from there on it's just how much you understand the theory to move forward. Okay, so what I want to start off with is this cube. It's a cubic graph. It has 3 x-axis intercepts. It's got 1 here, 1 here, and 1 here. Okay, so it's got 3, and I want you to focus on what we call the gradient. This is why I'm referring it back to year 9 mathematics. What is a gradient? And a lot of us will say it is the slope of a line, which is true. it's how steep a line is. And these are the things you've learned back in year 9, which is m. Gradient's the m. Gradient's rise over run. Gradient is y divided by x, or vertical over horizontal. Okay, and that's your ratio. What we're going to do is also we're going to add a couple of words in now. So this is your gradient. It is also the rate of change at each point. And I think at this point where a lot of students will go, you're confusing me now. Okay, what does it mean by rate of change at each point? What we're saying is that every coordinate on a graph, and the only reason why you see the graph is because there are infinitely many coordinates that make up a line. It looks like a line, but it's just infinitely many coordinates. At every point on the coordinate, there is a height and a distance. And so from the previous point, so from this point, actually I'll just pick another 2 points so it's clear. Let's pick these 2 points. There is a rate of change in the sense that, well, what's the change from this coordinate, let's call it x1 to x2, how far has it traveled? So say 1 to 2 means it's 1 unit change. Same thing height-wise, this could be, I don't know, the height-wise could be, let's just put a number in so you can visualize what I'm saying, 2 to 4, then you say that's 2 units. Whereas if I use -3 to -2, then you say that's a change of 1 unit. So for every 1 unit, I'm moving up by 2. So you'd say that's my rate. My rate is I'm moving up by 2, so y value is 2, and then my rate on the bottom is for every 1. But the problem is that that's only the rate for that particular point, or the average rate between these 2 points. And it's not linear. If it was linear, it makes sense that every rate increases. That's why your linear line, every time you go across 1, I don't know, you go at 4, 1 across, up 4. That's why you can write y equals 4x, which implies that for every 1x, increases by 4. Whereas in a cubic, that's not true, because from one end to the other, it might increase rapidly, and then it might decrease rapidly. And the rate changes, which is why we say rate of change. And what are we talking about in terms of change? We're talking about the change of y values versus x values, which is what you learnt back in year 9. Back in year 9, another way of finding out your gradient was you said y2 minus y1 over x2 minus x1. This is your rate of change, technically. That is your change in y values vertically, divided by which is the ratio with your horizontal. We just want to know the ratio for it. So we're saying, all right, well, the change of x is how much it moves horizontally, how fast, and how fast it is on the top. Because if the top is slow, meaning if the change vertically is slow, so it goes 1, 2, 3, whereas let's say the horizontal is really fast, let's say it goes 10, 20, 30, 40, then what you should see is the graph will look more like this. Increases slowly, it takes longer to increase, but horizontally it increases so fast. Then you see a flatter ground, which is why we say when you have 1 over 100, we say that's a very flat gradient, because the rate is so slow for it to increase. Whereas if I switch that around and I said 100 over 1, okay, 100 over 1 would imply that for every 1 unit, I'm now skyrocketing up, which is why you'd say it's very steep. Okay, now the problem with gradients is that if I gave you a gradient of 100 or a gradient of 400, so I'll just write m equals 400 versus m equals to 100. You all know it's steep, but you can't visualize how steep that is. Like if I said, what's 1 million x, which is the gradient, what does that look like? How steep is it? Are we talking about like a vertical line, or are we talking about 45 degrees? Like how steep is it? And that's when degrees comes in. You see, angles is easier. If I told you it was 88 degrees steep, you all can visualize that. You can tell me, oh, there, that's really steep. If I told you a mountain to walk up that 1,000 steps was 70 degrees steep, you're like, oh yeah, it's a bit more than 45, so that's quite steep. But if I said 25 degrees, you're like, oh, actually, maybe I can walk that. Okay? So the degrees is something that is useful to us, and That's later in the exercise where you're going to use the idea of a triangle, because that's what you're really doing. That's the steepness. And the triangle is nice because you can find the angle using trigonometry. And a nice thing is, this is your opposite versus adjacent. What function in your trig or circular functions allows you to have an angle with O and A in it? Tan. Which is why we also know now tan of an angle is actually telling you your gradient. I don't know if I talked about it in this class. Did I mention about tan theta being the gradient in this classroom? No? Just a fun fact in case you guys didn't realize, you know the tan graph that you learnt last year? Not many students realize, but this graph with the asymptote at pi on 2 and negative pi on 2, and it goes on infinitely, they don't realize that this graph is actually just the graph of your gradient. Because you think about it, in your unit circle, you go around the circle. What I want you to see is every time you go around the circle, look at the gradient. See, it makes sense that vertical gradient, that vertical gradient is 1 over 0 run. It makes sense that 1 divided by 0 is undefined. It's a 0 gradient, which makes sense at 90 degrees, pi and 2. It's undefined. You see, this is just a measure of your gradients as you move around the circle. See, if you pass that circle, that's a negative gradient. See, that's a negative slope. And that's why you pass, once you go in that direction, it goes negative. So if you draw if we draw the graph, it carries on like that. That's why it starts off so negative, because it's a very steep negative line right there. That's a very steep negative line, negative gradient, and as you keep going, when you hit pi, that's a 0 gradient. It's horizontal, which is why right there, when it comes to circular functions, you're just really sketching your gradient. You're analyzing how steep is the line as you're going around. And the nice thing is tan tells you the angle. See, now you know that tan of 45 degrees, which is 1, that tells me it's a steepness of 1. It's 1 by 1. Every time you go across 1, it goes up 1. And that's what tan of 45 degrees represents. It represents a gradient of 1, a ratio of 1. For every time you go across 1, you go up 1. Okay? But that's a bit something off, but just in case you didn't know that, I just thought I'd let you know that tan is really talking about the gradient, so keep this as a note. Tan of theta is opposite of adjacent, which actually is your gradient as well. Okay? Then you think about back to year 9 mathematics, you learnt all these gradients. You have positive, negative, 0, undefined. And again, you know, positive because you got, let's say, 3 over 4. You see that's a ratio, but they're both positive, and naturally if you went across 4 and you went up 3, that's what your positive gradient looks like. That's why we say that's a positive. And then if you had negative 3, 4, that implies that you go down 4, because negative 3 implies down rather than up, which is why if we went down 3 and then across 4, then of course this is my negative line. So we call that the negative gradient. And then if you tried 0 over 4, so you don't rise, but you go across 4. So if I don't rise and I go across 4, then it makes sense that it becomes a horizontal line, which we call 0 gradient. And similarly, if I then changed it to 1 over 0 or 4 on 0, it just means go up by 4, but you don't move left or right, which is why we say that's a vertical line, and we call that undefined, because 4 divided by 0 is undefined. Okay? Why do I emphasize these year 9 mathematics here and a bit of a sort of circular functions year 11 is because that's what you're really doing this whole chapter on calculus, differentiation. You are simply analyzing one thing, and that's your gradient. You are analyzing at every point, what is your rate of change? What is the gradient? Is it steep, flat, maximum, negative, whatever it is? You're just looking at the gradient. So, an example would be, these are all the lines so you can see. An example would be at that coordinate there that I have. Drawing a tangent line. Tangent line is a straight line that touches that point once. Okay? Tangent line is a straight line. A straight line has a gradient. So every point has a gradient. This is a positive gradient. This is a 0 gradient. If you were to draw a tangent line. Oops, 0 gradient. And then if you did a tangent line at this point, that's clearly a negative gradient. So you'd say, okay, negative gradient. And then if you keep going to the other point, that's now again a zero line. So you call that zero gradient. And you carry on to this point, and then you say, well, that's a positive gradient. Okay? So what do you see is why last year when we talked about stationary points or we talked about finding maximum minimums, the pattern that we found is that every time you change the steepness of the line at every point, every time you reach the maximum or the minimum, it's very obvious that the line is horizontal. That's why they say to find the maximum minimum, let dy dx equal to 0. It wasn't just a random rule. The idea was we're just saying the gradient is 0 and a maximum or minimum, which makes sense because you're just analyzing the graph and you're like, oh wait, every time you reach the maximum, the rate of change is 0. Rate of change meaning that you're not going up or down, you're just moving left or right. And that's why it becomes 0 and 4, and we call it a zero gradient. So that's why you say let that equal to 0. This just means gradient. Another way of looking at it is just this. M equals 0. And you solve for x, and that just tells you where you have a gradient of 0. Where would you have a horizontal tangent line? That's it. Okay? So, going back to my whole point about this slide, we're analyzing gradients. Everything in calculus is just on this one concept. So I said the one concept's very easy. It's when I put in letters and whatnot that you might get confused. But the only thing I want you to always fall back onto is a gradient. Simple as that. Rise over run, y2 minus y1, distance between the vertical, distance between horizontal. Ratio between the two, and that's your gradient. Okay? So it doesn't matter what problem they give you. If it's a calculus problem, think back to this, because it's a very simple concept. The question might sound hard, but it's a very simple concept. And I'll give you some past exam questions so you can see how they take a simple concept and they write it out in a way that it seems hard, but it's not hard. Okay? Here we go. Let's have a look. Gradient of the tangent for x squared. So we're looking at this x squared. We'd say that y gradient is y2 minus y1, x2 minus x1. Okay? Now, this is what I want you to understand, and I'm going to draw it over here so you can see. This is where the first principles come. Every rule that you learnt last year came from this one theory. Okay, now you're not expected to remember how to do first principles, but you need to understand what it means. Okay? First principles is still just following this y2 minus y1, x2 minus x1. Take the example, let's say this is x1, so this is coordinate, the first coordinate, and let's say this is x2, this is your second coordinate. Okay? What they're saying is, what is the gradient, the average gradient between those two there? Okay? You would say, all right, well, what they did was they said, what if I called this x, and the next step is, let's move h amount. If I moved h amount, this will now give me x plus h. Okay, now a lot of kids will get confused because I'm using letters. What I'm saying is, what if this was a 3, and the distance to the next one was 0.1? Then you would say 3 plus 0.1 will give me the next coordinate, x coordinate, as 3.1. True? Yes? Okay, so from 3, distance to 0.1, I do 3 plus 0.1 gives me 3.1. So it's just two different x coordinates, x1, x2. Yeah? Then I ask you, well, to find the y coordinates, if this is my function, f of x equals x squared, if I asked you how to find the y coordinates of these values, what would you do? How do you find the y coordinates? At x equals 3, what's my y coordinate there? How would I find that out? What do I do? I heard sub what? Whoops. Sub what in? Yes, Josh? Yeah. You just sub 3 into where your x squared is, and that's where you get your y value from. Yes, Layla? Yes, you may. Okay. So what I'm really saying is this. I'm going to draw it all again so you can see. I'm just saying, if this is x, to find out this coordinate here, you'd say x, the y coordinate is based on that. So if you know this was 3, if this was 3, then you say f of 3 will tell me what the y coordinate is. So if this was 3, so if I just rewrite that, 3, f of 3. True? Okay, x1, y1. If the next point was 3.1, to find the y coordinate, you'd say, well, at 3.1, to find out, you just sub 3.1 back in. True? Now all I'm going to do is I'm going to rub off the numbers and I'll put in letters. Okay, same thing. There's no difference. Okay, I'm going to rub off the numbers. I'm going to put the letters in. It's the same drill. So here we go. I'm going to put x there. If this is x coordinate, then to find the y coordinate, you would sub x into the function. So if I sub x into the function, it will be f of x. Agreed? Okay, so this will be f of x. So that's x1, y1. If I have the second point, if I said it moved across by h, and this is now x plus h, moved an x h amount, then you'd say the next coordinate or the point would be x plus h, that's my x2. y2 would be f of x plus h. Agreed? So what I'm going to do is I'm just going to write in red so you can see x2, y2, x1, y1. I'm still going back to year 9 maths again. Two coordinates to find the gradient y2 minus y1, x2 minus x1. Yeah? So I've just called this x, x1. To find out the y1, you sub it back in. Yeah? So now we're going to do what we learnt in year 9, y2 minus y1, which is x plus h squared minus x squared. Now if you're wondering where that came from, it was from here. I said f of x equals to x squared. So if I have f of x plus h, because remember this is my x coordinate, if I sub this in, if I put it in here, then what am I putting into the machine? I'm putting into x plus h squared. So that's my y2. See? F of x plus h must be subbing x plus h in squared, gives me that. Now the nice thing is all you're really seeing there is x plus h squared minus x squared, and this is your x2 minus x1. So if you just simplify it all down, you can see that x minus x cancels out. You've got now x plus h squared minus x squared, that is your y2 minus y1, and you've got h at the bottom. What does this tell you? This is just, I know all the letters might scare you, but all it is the gradient from P to Q, or any two coordinates. So, what's the theory of the first principle? The theory of the first principle says, well, if we said h was a distance away from x, what if h was so small? What if the distance is so small? Because right now I'm choosing between these 2 points. What if I made it smaller? You see, if I made it smaller, let's just have a zoom in look. Let's say this is P, and I made h this distance. Okay, and that's Q now. Instead of it being over here, I make it smaller. What you can see is the gradient changes. It changes from here to here to being closer and closer. You think about it, it was either from here to here, from here to here, from here to here. Now, it's getting closer to the tangent or the gradient at P. Because what's the problem with finding gradients? You need two coordinates to find a gradient. What if you want to find the gradient at one point? Because that's the whole point, isn't it? That's everything you've been doing so far from year 11 was you get a point and I said, this is your coordinate, find the gradient of your tangent. How do you find the gradient of a tangent if you only got 1 point? You don't have two. So what they're saying is all right, let's hypothetically say that the second coordinate, Q, is so small, the distance between them is so small, can you approximate it such that it is equivalent to the gradient at the exact point? That's what the first principle is talking about. And this is what your first principles look like last year. Okay, let's just move forward. This is your first principles last year. I said limit of h approach 0, and you got f of x plus h minus f of x over h. And a lot of you would have been like, oh my god, what is all that? I don't understand this. All this is really saying is y2 minus y1, x2 minus x1. That's a gradient. What's this limit of h approach 0? They're just saying, what if the distance was so small? What if I made that distance between x and x plus h so small? Because what if I made this h literally almost right next to it? Wouldn't it actually give me that line? And so that's what you've been doing. You actually literally use the first principles to find the gradient. And if we try to do this mathematically, to find the derivative of x squared, anyone remember how to find the derivative of x squared? What is it equal to? 2x. Yeah, bring down the power and you minus the power by 1. Gives you 2x. Let's see if it's true. If you expand x plus h squared, gives you x squared plus 2xh plus h squared. Minus x squared, you simplify that. X squared minus x squared cancels out. Divide all the h's because they're all over h, so the h's cancel out. You get this next step, which looks like that. And if you're saying that h approaches 0, h is so small. If h is so small, you naturally get 2x, which is exactly what that is. You told me just now the derivative of this is 2x, and I've just shown it using the first principles. But the rule that you learnt last year to differentiate that, that's someone else who figured it out for you. They only figured it out because of this rule, which is that concept. This principle allows you, and there's a proof on the slide if you want to have a look at it, using this proof to actually prove that you have f of x equals x squared, and the derivative, you bring down the 2, and 2 times x2 minus 1. This only works, this rule only works because this existed. And this only existed because someone noticed that if you made h really small, it's technically the same as finding the gradient at that one point. Okay? That's what it really is. So don't be afraid of this, because when you're going to look at exercise 9A, if you read the question and look at the symbols, it looks scary. Don't. Picture it. Because what I just showed you is just 2 coordinates, and you're finding a gradient of 2 points. And I'm going to show you what I mean later, so you can see that it's nothing scary. It's just 2 coordinates, y2 minus y1, x2 minus x1. Okay? Simple as that. Chapter 9 is just simple as that. Nothing more, just a gradient. Okay? Any questions on this before we actually get into mathematics now? We actually do the algebra. That was the theory. Alright, keep in mind, I'm going to keep reminding you for chapter 9, okay? Chapter 9, gradient. Chapter 9, every question you're ever going to ask me, I'm going to bring you back to Year 9 mathematics on gradient, okay? Because that's all I want you to drill in your head. Chapter 9 is just a gradient analysis, okay? Here we go. This just tells you the gradient at every point. Okay. In case for those who are having issues with using the first principles, this slide will teach you. Okay? So, for example, f of x, if this confused you before, I'm going to just quickly show you the f of x and f of x plus h. Okay? So this is x, this is y1, y2. Yeah? So if you remember the little graph I drew before, I said if this is x and this is x plus h, so x1, x2, this coordinate here will tell me x plus h and f of x plus h. So hence x2, y2. Yeah, that's all I'm saying here. x1, y1. Okay? So, now that you know this, let's have a look at this example. They're just asking you in exercise 9A, use first principles to find the derivative of this. Now I know I can use power rule to find out the answer, but I want you to think about it in first principles. Okay? First principles. F of x plus h, okay? It just means if this is f of x, if I sub x plus h into this equation, what will I get? Instead of x squared, I get x plus h squared. So it becomes 3x plus h squared. Plus 2 times x. Now instead of x, I'm going to replace that with x plus h. That's why I get 2 times x plus h. Okay, so that's my y2. Then I have this. This is y2. I colored in red for you. y2, which is up here, minus y1, x2 minus x1. Now remember, x2 was x plus h minus y1. You notice that these will always cancel out. That's why I don't write them. Okay, so x2 minus x1, you're left with h. Now, see from here, it's just about simplifying the numerator. So if I simplify the numerator, I expand all these brackets here. Looks really hectic and ugly. That's why it's a year 11 technique. You expand it out, simplify it, all the negative 2 plus 2, negative 2x plus 2x, negative 3x squared plus 3x squared. You're left with 6xh plus 3h squared plus 2h. Divide all the h's. You get this. And then if h approaches 0, notice I kept the limit of h approach 0 throughout the whole entire calculation until I get here. See, when did I remove the 3h is when I actually applied as h gets really, really small. A really small number times 3 is a very, very small number. So you can just say it's 6x plus 2. That's what I've done here. And if you use power rule for this one, that's true. Because you drop down the 2. 2 times 3 is 6x. 2 minus 1 is 1. And this is 1. Bring down the 1, that comes 2. And then derivative of 2 is 0, which is 6x plus 2. Okay. Did you know you were going to tell me again? No? Okay. That's if you want to do this again, okay? First principles, last year's technique, if this is anything you want to practice, okay? That's 9A. Now, 9A, no, don't worry, this is B for you to practice if you wanted to check. Here we go. Let's have a look at this. 9A, I'm just going to have a look at question 2. I want you to have a look at it. Think about it. I'm going to silence my phone. I think it's the builders calling me. Okay, here we go. So find the average rate of change of the function with this. Now what's confusing about this line? Let me tell you. Right here. If you're wondering what that means, the gradient. Okay? That's all I said. This whole chapter is all about the gradient. What is it asking? Is it says find the gradient of the function with rule there as x changes from -1 to 1. So visualize this. Visualize the graph. I don't care what 6 minus x cubed looks like. Okay, let's just say it looks like this. All right, make it up. The whole point is I'm saying from -1 to 1. So I could have from -1 to 1. Average rate of change means find the gradient from this point to this point. You got your x1, x2. How do you find your y1, y2? How do you find your gradient? Gradient was y2 minus y1 over x2 minus x1. Suddenly it's all back to year 9 mathematics. Nothing scary. If you know your x coordinate, how do you find your y coordinate? What do you do? Yeah, you sub back in. This is your function. So if you want to know at -1 what your y value is, just do f of -1. Sub -1 in, and you'll know the y value. And if you know this coordinate is 1, how do you find the y coordinate? Same thing, sub 1 in, so f of 1. There you go. You got your x1, x1, y2, x2, y2. Use the gradient formula in year 9. Work out your gradient. Why is that hard? The language. Chapter 9 is all about gradients. That's all you got to do. Okay? I'm going to get you to practice a bit before I get to exercise 9B using the rule. Let's have a look. Don't worry about the limits. You can look at the limits. That's a limit page. Power rule. Oh. Where's the textbook? Oh, I didn't put the textbook in. Alright. Let's get you to practice a bit on 9A before I go into 9B. Okay? I will do it in the second half. Let's find your textbook in case you don't have a textbook with you. Here we go. Pick a few questions from 9A. The questions, sorry, in case you didn't know which questions to do, I've posted up on Schoology. And I printed it out actually, I need to go cut it. I'm going to leave this up and I'll go cut your sheet so you know which questions to do, okay? But remember, study smart, don't study hard. Study smart. Pick the questions, if you get it, move on. So if you're doing second one, you got it, you got the right answer, move on. If you're doing a few of these, you got it, move on. Okay, don't waste your time doing every question. Pick a few questions, you got it, move on. Here you go. Questions?
There's one direction you right?
That'd be negative 2. No,
We don't always have time.
Where did you get 2 from? 2?
I'm looking at what
Should be 2 anyway. Okay. Please keep it.
Let's go. Just practice the questions, and then we'll go to 9B. Cow rule and angle.
Most of them are
If you feel that you know 9A already, move on to 9B. Look at the questions. Look at 9B. 9B is very long. It's lengthy. But if you understand the concept, you should be able to do all of them.
What do you got next one?
Is there a spare? Question?
Yeah, it is if you already understand it. Anything in the class is optional.
It is all optional. You're all in charge of your Year 12 results.
Already?
Yeah, I can.
That's
Don't
like
do any
good
work.
work.
Yeah, you're probably going to be able to do
No. If I get it, I can probably do it. And then you just do a bit extra super fast at it. And really accurate. And you've got your focus way up to it. You know?
So this is the range now. The range is -infinity to 2.
Yeah. I think I got it right. Because it matches with that domain.
The main is real numbers. So
No, the domain is negative infinity.